Hi there, my name is Pauline Lau. Thanks for tuning in to my process video based on my group's art installation entitled Insane in the Brain. My group and I took inspiration from the interdisciplinary learning domain of thinking processes as the overarching theme to generate our art piece. According to Oswell's 2015, thinking validates existing knowledge and enables individuals to create new knowledge and to build ideas and make connections between them. Today I will be discussing the two curriculum learning areas of mathematics and music within the arts domain. As stated on the art installation website, we have developed a piece of art that could be used as a teaching resource within an integrated arts program, such as one that interconnects maths and music together. It is widely believed that students who do well in music also excel in mathematics. Just like the human brain, mathematical ideas are constantly developing. As stated in Oswell's, the Australian mathematics curriculum aims to ensure that students develop an increasingly sophisticated understanding of mathematical concepts and fluency with process, and are able to pose and solve problems and reason in number and algebra, measurement and geometry, and statistics and probability, as well as recognize connections between the areas of mathematics and other disciplines, and appreciate mathematics as an accessible and enjoyable discipline to study. Music can be simply integrated into the mathematics curriculum, for example by chanting times tables with rhythmical movements around the room, bringing together a common element of maths and music, which is time. Insane in the Brain can be incorporated into a time lesson or inquiry unit by focusing on the shadow that moves from one edge to the other along the lower quadrant of the video, thus pertaining to a culture of making predictions and interpretation of how the sun and the shadows it casts can help us to tell time. Additionally, Insane in the Brain can be tied in with the interdisciplinary learning domain, thinking processes. The thinking processes domain encompasses a range of cognitive, affective, and metacognitive knowledge, skills, and behaviors which are essential for students to function effectively in society, both within and beyond school. Aligning with these principles are de Bono's thinking hats and their potential application in a mathematics music lesson. A traditional mathematical learning sequence using 2 of the 6 thinking hats reveal that new information with the incorporation of rhythm, beat, or melody can provoke an emotional response. In other words, one's attitude or feelings towards a concept or topic, which can lead to newly formed procedural and knowledge-based understanding. Moreover, Geist, and Kuznick 2012 convey that research conducted on music and music therapy suggests that mathematics and music are closely related in the brain from very early on in life. Musical elements such as maintaining a steady beat, rhythm, and melody share mathematical principles such as spatial properties, sequencing, counting, and patterning. Furthermore, research conducted by Zentner and Erola 2010 found that children were more engaged with rhythm-only stimuli than with speech-only stimuli, thus indicating that children have the potential to be more engaged when listening to steady beats than when listening to verbal-only instructions. Therefore, it can be argued that listening to a steady beat pattern during a mathematics teaching activity could promote better attention and increased engagement in young students. Due to the broad nature of the installation, Insane in the Brain can be utilized as a teaching resource in a literal interpretation of the human brain and its thinking processes through the implementation of the de Bono's 6 thinking hats, as well as an inquiry starting point based around the concept of movement, time, and natural sounds, tying in sustainability and the environmental themes such as the sun, shadows, clouds, and wind. Thank you for watching my process video.